Hello class, this is a video tutorial on the reciprocal of functions, part 2. In this video, we'll be going straight into two examples where we apply all of these properties of reciprocals to this function here and this function here. So you can go ahead, pause, and give this a go yourself. A good way to do this is just, I know it's really difficult to sketch these, but you can pause and just visualize what it would look like as the end result. So here we go. Now, as I mentioned before, it's best to try and find X-intercepts first, because at those points we can definitely find a vertical asymptote. So the first vertical asymptote that we can definitely see is this X-intercept at x equals 2. So there's a vertical asymptote here. Let's just extend it as far as it'll let us. Let's make it a little bit thicker and dotted lines. There we go. This is a regular polynomial. It's just a quadratic or parabola. So there is a horizontal asymptote at y is equal to 0. Let's do that in red. Let's make it a little bit thicker and dotted. There we go. Now from here, let's start sketching what this should look like as we approach these points. So for example, as we move to the right, okay, so as we are approaching positive infinity, this point here states that the reciprocal approaches 0. So we already know that there's a horizontal asymptote very close to the line y is equal to 0. But then let's find a few points that we can find the reciprocal of. Like for example, this point here, it has a y value of -1. When we take its reciprocal, it'll become y equals 1 over -1. So our reciprocal will actually intercept that point, right? We can assist our sketch a little bit more by picking, let's say, this point here. At this point, it should be half, which I quite accurately sketched. At this point here, because it is -4, sorry, its reciprocal will be y is equal to 1 over -4, which is -0.25. So if we were to sketch this more accurately, that's half. At this point, it should be at 0.25, so at that dot there. So these three dots I can already see. We can connect them three. Should be something like that. Now from here, let's take a look at what's happening. As we are approaching 0, we already know that this is going to shoot upwards like so. So let's make this a little bit more accurate, why don't we? At this point, we have y is equal to half, or -half, -0.5. Its reciprocal will be 1 over -0.5, which if you calculate will become -2. So at this point, it will become -2. So that's half. This is a quarter from the looks of it. At a quarter, so 1 over -0.25. 1 over -0.25 will become -4. So this point will become here. So I hope that's already enough for us to visualize what's happening with this asymptote. So it should become something. And I'm just going to cheat and make a straight line going vertical like so. Hope you get the idea that there is a asymptote that runs very close and then runs very close to like that. Now, because this is a parabola, and we know that it is symmetrical around the vertex, this is actually going to look identical on the right hand side as well. So it should look near identical on the other side. So it should be, not should be, it is actually identical on the other side. So very carefully trying to sketch this, going a little bit closer, and then just drawing a straight line. There we go. Oops. And there we have it. And going along here, whoops, going along this way, it's really close. And then we're just going to draw a horizontal line like so. So that there is the function, or the reciprocal of this function here. Alright, so hope that gave you an insight into this. You can pause and give this a go yourself. This one is a little bit harder because there's a few more things going on, but I hope you can pause and give this a go yourself. So here we go. Let's first find the vertical asymptotes. So wherever there's an X-intercept, we have a vertical asymptote there. So let's sketch that in. Actually, I can copy this, just take it from here. We have a vertical asymptote here and here. Since this is just a regular polynomial, it's just a cubic, I'm going to take our horizontal asymptote, and we already know it's going to be at y is equal to 0. All right. Okay, so now we know that as x approaches infinity, we already know there's going to be a asymptote going something like this, right? So let's take a look at how we might sketch this a little bit more accurately. This point here is y is equal to 5. Its reciprocal is y is equal to 1 over 5. So this is half, this is a quarter, which is 0.25. So very close to this is 0.2, which is 1 over 5. This point, let's pick this point here. This point here is 2. Y equals 2. So this point is y is equal to 2. Its reciprocal will become 1 over 2. So that point there. This point is 1, so its reciprocal is 1. So already we can draw the curve that should look something like this. And then I'm just going to cheat and make a horizontal line because it's very hard to draw horizontal asymptotes. Likewise, this point here is half, and at this point it will become 2 because it's reciprocal. So this point here is y is equal to half, or 0.5. Its reciprocal is 1 over half, which is 2, which is what I've plotted here. So just using those points I feel is enough, so we can now just continue this sketch. And I'm just going to draw a vertical line to symbolize that asymptote. And there we have it. Now let's focus on this right hand side. In a similar way, we can bring this already. We know there's going to be an asymptote going across like this. And at this point, it's -1. So we know it should intersect at that point because it's reciprocal. So this point here is y equals -1. Its reciprocal, 1 over -1, is also -1. So we know it's going to curve and intersect at that point, and then very rapidly become that asymptote, that vertical asymptote we're familiar with now. And lastly, we need to focus on this bit here in the middle. Well, as we've stated, this is a maximum and its y value is 2. So therefore, when we take its reciprocal, it'll become half. At this point, it's 1, and at this point, it's also 1. So, and I pick those points because those are the reciprocals. So that is y is equal to 1. Its reciprocal is y equals 1 over 1, which is also 1. Okay. Likewise with this point here, its function value, the orange one, is y is equal to 1. When we take its reciprocal, we get 1 as well. Now from these points, I hope you can already visualize what this is going to look like. As you can see, this one is decreasing more rapidly. Therefore, its increase on this asymptote is already super close to that line, so like so. Whereas this one, notice how it's not as steep, meaning it'll have a near equal gradual increase. Like, oops, let me try that again. Like so. So that there is the reciprocal of the function in green. Alright, so I hope I gave you an insight into sketching reciprocals just from the graph of the function. So I hope to see you in the next video. Best of luck.